So now in section 6.5, we're talking about operations with radical expressions. Okay, so one of the things that we can go back to and talk about is back when we talked about square roots, we talked about how if you were taking the square root of 2 times the square root of 8, it's the same as the square root of 2 times 8, which is 16, right? And that equals 4. And the same is true with third roots and fourth roots and nth roots all the time. If you want to know what the nth root of a times b is, so two numbers multiplied by each other, it's really just the nth root of one number times the nth root of the other. And so this might be really beneficial when we're starting to have numbers and variables together, right? So let's look at this one right here. We're looking for the square root of 32 times the square root of 8. All right, and we've looked at problems like this before. It's breaking them up into things we do know the square roots of and things we don't, right? So we got to think of some factors of 32, all right? So what are some things that break it, and we can break it down all the way down as far as we can to as many factors as we can, or as big of a square root that we know. Now, for me personally, I know that the biggest square root that can come out of 32 is 16 and 2, right? And I know what the square root of 16 is. It's 4. But I don't know what the square root of 2 is. So I'm going to leave that in there. Then I also know that the square root of x to the 8th is x to the 8 divided by 2, which is x to the 4th. So what I'm going to do is I'm just going to keep all of these in my answer. So my answer for this one, the square root of 32x to the 8th, is going to be 4 square roots of 2 x to the 4th. That's my answer right there, okay? Let's look at problem B. I'm looking for the fourth root of 16. Now that's a little bit trickier, okay? So the first thing I'm going to do is I'm going to check decimals to see if I can actually take the fourth root of 16. And I say 16, the power of 1/4, I get 2. So that's kind of nice. We know that it's going to be 2, all right? So this for sure is going to be 2. Now I take and I say, can 24 is a to the 24th divided by 4? Is that a perfect, or is that a whole number? And the answer is yes, it is, because 24 divided by 4 is going to be 6. So we're going to have a to the 6th power. Now the problem comes in with letter B, b to the 13th, right? 13 divided, make it look a little nicer, 13 divided by 4 is not a whole number, right? But what I do have is 12 divided by 4. So b to the 12 divided by 4, which is going to be b to the 3rd. But then I also have that 1 left over. And so that's going to be b to the 4th root of b. And so we're going to write it like that. We're going to say b to the 3rd, and then the 4th root of b is in our answer as well, right? So we can take the 4th root of 16, okay? 4th root of 16 is 2. The 4th root of a to the 24th is a to the 6th. And the 4th root of b to the 13th is b to the 3rd, and then 1 more left over. Okay? And I'm going to write it like this. Another way you could have written it, okay, and maybe you'll see this later on, would be b to the 3rd times b to the 1/4 power, right? Okay? And so that would be something that you would just have to look at. I'm assuming you're going to see this one a lot more. Okay? All right, so here's a couple guided practice problems that you can try now in the video. All right, so now there's also, if we can do it with multiplication, we can probably do the same with division. And so that's called the quotient property of radicals, right? And so what it says is if I'm looking for the nth root of a over b, it's the same as the nth root of a divided by the nth root of b. And so sometimes that's going to look really nice, like for something like this, right? So it's the square root of 27 over the square root of 3, which is the same as the square root of 27 over 3, which you know to be 9, which is then 3. So you take two square roots you don't know and divide them, and you actually end up getting a whole number, which is kind of sweet, right? And so the same thing can be true when we're looking at nth roots of variables and stuff like that, right? So right here, the 3rd root of x to the 6th right there is going to be x to the 2nd. And the 3rd root of 8 is going to be 2. And so I can write it as x squared over 2. That's how I would write it. Or you could write it as 1/2 x squared. Both are correct, right? All right, so some interesting information right here is When we have a square root or a third root or something like that on the bottom of a fraction, we don't like it. And so to get rid of that, what we do is we multiply the radical by itself, because you know that the square root of 3 times the square root of 3 is really just the square root of 3 squared, which is just 3, right? And so we always want to have whole numbers on the bottom. And I know that seems like a little bit extra work, and I know that seems like some more steps, but we have to do it. It's one of those rules with math. We don't like square roots on the bottom. Now, with square roots, it was easy. We multiplied it by that. But when we have a different one, like a third root, I already have one third root there. So to make it a whole number, I have to have 2 more. And so we multiply it by this, which is the square root of, or the third root of 2 more times. So we say 2 squared, right? And we're going to look at a problem like that in just a second. All right, so my job is to find the square root of x to the 6th over y to the 7th. Now, you don't have to do this step, but I still like to do it every time, just because then I know that I'm doing something right. Okay, so I broke them both up. I know the square root of x to the 6th is x to the 3rd, but the square root of 7 is going to be, the square root of y to the 7th is y to the 3rd, but with another square root of y. And so I want to get rid of that, right? And so the nice thing is square root, I'm just going to multiply the top and bottom by square root of y. And you might be asking, why? Okay, no pun intended. But the reason we have to do that is because I have to get rid of this right here. And so square root of y times square root of y is just another y. So on the bottom, I had 3. I'm adding one more, so it's going to be y to the 4th on the bottom. And the top, I don't have to do anything more than write x to the 3rd square root of y. So I'm okay with square roots on the top. I'm not okay with square roots on the bottom, or nth roots or whatever. Okay? So let's look at letter B. Okay, I'm looking for the 4th root. Okay, so I'm going to write that, the 4th root of 6 over the 4th root of 5x. Okay, now, can I take the 4th root of 6? Is that a nice number? Okay, well, let's look. Let's check decimals, right? So I'm going to say, the nice thing is 1/4. I'm just going to do 6 to the 1/4. And I see that it's a decimal. And so I don't like decimals, right? So I can't do that. But I can say, is there a number that I can take the 4th root of out of 6? So I think of its factors, which are 3 and 2. And so the answer is no, I can't do that. So I'm just going to leave this right here, the 4th root of 6 right there. But I still have to get rid of the 4th root on the bottom, right? And so far there's 5x. And I need 3 more of them. So I'm going to multiply it by the 4th root of 5x to the 3rd. And I also do the same, the 4th root of 5x to the 3rd on top. Now you'll see that I have one of them here, 1, and I have 3 more. When you add them, there's going to be 4 of them, which gets rid of the 4th root on the bottom. So I end up getting, right, this. I get 5x on the bottom, okay? The 4th root and the 4 of them canceled out. And on the top, okay, I'm going to simplify this. Well, 5 to the 3rd, if you wanted to do this on a calculator, is 125. And x to the 3rd power is x to the 3rd. So I'm going to have the 4th root of 6 times 125 times x to the 3rd. And so my final answer, I'll write it here in black, is going to be the 4th root of, well, 6 times 125, I'll do that on my calculator, is going to be 750 x to the 3rd all over 5x. That's my final answer. And a lot of times people ask the question, well, it goes from something that looks easier to something that looks harder for the answer. But this is technically the simplified answer, and we no longer have that 4th root on the bottom, right? And that's what we're going for. We're going for getting rid of our 4th roots or nth roots on the bottom. Here's a couple problems that you can try now here in your notes. Okay, so here are the rules for simplifying radical expressions, okay? First, we want to get n to as small as possible, right? That's our goal to do it. We also want to get no factors other than 1 that are to the nth power of an integer or polynomial. That's like in our example when I didn't just leave it as this, 5x to the third underneath the radical. I actually simplified it out, and so that I had 750 in the end, right? It contains no fractions. That's where that idea of like getting rid of fractions underneath the radicand seems like it's more work, but it's actually, that's how we simplify. And finally, the last one is no radical appears in the denominator. So that's why we had that 5x on the bottom. We no longer had a fourth root in the bottom. That's what we do to simplify radical expressions. Again, this sometimes is going to seem like more work, but there is a method to the madness, right? Okay, so now what we can do is we can apply our properties of product and quotient to simplify some problems, right? Okay, so if I look at this one right here, okay, the first thing I notice is that I have a 5 and a 3 on the outside. Well, that's easy. 5 times 3, I know what that is. It's 15. The other thing I notice is that you notice the index 3 is the same in both of them, right? So that's really easy. That's really nice. So I'm going to start with a third root then. And now I'm going to, since they're the same index, I can just multiply the numbers. So negative 12 times 18, negative 12 times 18 is going to be negative 216. Okay, I can take a, and then I have a to the second, which would be a to the third. Okay, and then finally I have b to the fourth and b to the second, so that's going to be b to the, okay, think about it, is it power to a power? Are we adding or multiplying? And the answer is we're going to be adding these. So this is going to be b to the fifth. Okay, excuse me, sixth. 4 plus 2 is 7. Okay, b to the sixth. All right, so now what we can do, right, is we have our 15. I'm going to drop it down and say, this is 15. Now, can I take the third root of negative 216? All right, well, let's go to decimals. Let's check it out. So negative 216 to the 1/3 power is negative 6. The nice thing is notice it's a negative answer because I have a negative in there. All right, so this is going to be negative 6 right here. The next thing I notice is that a to the third divided by 3. That would be a to the 3 divided by 3 is just a to the 1. And then b to the 6 divided by 3 is b to the second. And so I combine all of this stuff together, and we say 15 times negative 6 is going to be negative 90 ab squared. So there's a problem where it goes from a bunch of stuff to something that looks really nice. That's how we can simplify. Okay. Again, here's 2 problems that you can try in your notes to attempt these, okay? All right, now, what we have to do now to add and subtract like radical expressions is kind of like how you add and subtract fractions. You have to have a common denominator. Now, if I want to subtract these right here, square root of 98 and square root of 32 are not the same. So my job, what I have to do is I have to make it so that our square roots are the same. So the best thing to do is to break this down as deep as we can. Okay, actually, you'll notice right here. Like terms would be square root of 3b, and we have square root of 3b here. Unlike terms, square root of 3b and third root of 3b are different. Okay, and again, square root of 2b and square root of 3b are different. I can't add those, right? So what we're going to do is we're going to break these down as far as we can, right? We're going to break it down as far as we can. So 98, I don't know what all the factors are, but I do know that a 2 comes out. So I'm going to say 2, and then I get 49, which is a perfect square, right? If I take the square root of 49, that's 7, and the square root of 2 is just going to be square root of 2, right? That's what those two are together. So I'll rewrite this as 7 square roots of 2. Now I go over here, okay, 32. I think about it. That's 16 and 2. Well, the square root of 16 is 4, right? And the square root of 2 is just square root of 2. But I also have that 2 on the front, right? So 2 times 4, that's going to be 8 square roots of 2. And now I'm going to add subtraction in there. So you'll notice square root of 2 and square root of 2. So my answer is going to have a square root of 2 in it. So 7 square roots of 2 minus 8 square roots of 2 is going to be negative 1 square roots of 2. Or you could just write it as negative square root of 2. Okay? So I get a common radical so that I can add or subtract it. All right? So here's a couple guided practice problems that you can try. Okay. In fact, why don't we try letter A together right here, and you can try letter B when it comes time for your video. All right. So 8. I can break that down into 4 times 2, right? Well, the square root of 4 is 2, and the square root of 2 is square root of 2, and I multiply that by 4, right? I do the same here. That's 25 and 2. The square root of 25 is 5. The square root of 2 is square root of 2, and I have that times 3. And so what I end up getting is 8 square roots of 2 plus 15 square roots of 2. And so my answer is going to be, well, 8 plus 15 is 23 square roots of 2. Now, if I went too fast, make sure you slow the video down, rewatch it, whatever you have to do so that you notice that these right here are going to be the same. Okay? All right. Now, the same is true when we multiply numbers with radical expressions, right? And so we actually can apply FOIL method to this. So 4 square roots of 3 times 3 square roots of 2. Well, 4 times 3 is 12, and square root of 3 times square root of 2 is square root of 6. Okay, so we look at that. That's our first term. Then we go to the outside, right? And so 4 times 6, negative 6, is going to be negative 24 square roots of 3. Okay, so hopefully you see how I got that. Then I get 5 square roots of 2 times 3 square roots of 2 is going to be positive 15, and then square roots of 4, which you're probably seeing. Oh, I know what square root of 4 is, right? But we'll get to that. And then the last one is right here. It's going to be 5 square roots of 2 times negative 6 is going to be negative 30 square roots of 2, right? And so what I can do then is I can go and say, can I simplify this any farther? Well, the square root of 6 is just a number. It doesn't break down into anything nice. It's just that. So we're going to write this as 12 square roots of 6. Then 24 square roots of 3 is the same thing, right? Now, square root of 4 is really just 2, right? So 15 times 2 is going to be 30. And then I have minus 30 square roots of 2, right? And so all of this cannot be combined any further, right? I can't break anything down. And so this is technically our answer right here, right? That's our answer right there. Simplified as far as we can, right? There's nothing more we can do. So here's a couple examples that you can try on your own as well. All right. Now, the last thing we're going to be talking about here is what happens if you have a square root on the bottom, right? And so we talked about conjugates back when we talked about irrational numbers. We called them complex conjugates, right? That's how we got rid of i's on the bottom. The same can be done with square roots, right? And so what we're going to do is we're actually, if I look at this problem right here, example 6, here is my problem, right? That's what I have to simplify. And so what I'm going to do is I'm going to multiply it by its conjugate. So I'm going to multiply the top and bottom by square root of 5 plus 1. And why do I use square root of 5 plus 1? I'll show you. Square root of 5 times square root of 5 is just going to be 5, right? Square root of 5 plus 1 is plus square root of 5. Square root of 5 minus 1 is minus square root of 5, which, okay, we'll talk about that. And then minus 1 plus 1 is going to be minus 1. Then I multiply the top. 2 times square root of 5 is 2 square roots of 5. And 2 times 1 would be plus 2. And so what we end up getting here is this square root of 5 plus and minus cancels out. And 5 minus 1 is going to be 4 on the bottom. And so I get 2 square roots of 5 plus 2 all over 4. Okay, now technically this is an answer. It's not the simplified answer. And so what we're going to do is we're going to simplify it as far as we can. And we notice I have a 2 here, a 2 here, and a 4 here. So I can take a 2 out of everything. And so I'm going to say 2 square roots of 5 plus 1 all over 4 actually simplifies to be, here, I'll write it over here, square root of 5 plus 1 all over 2. That's my final answer right there. Okay, here's a problem that you can try. It says the area of this rectangle is 900 feet. Okay, write and simplify the equation in terms of x. Okay, I'll have you attempt this problem. You're going to have to know a couple different things right here and know that this is a 60-degree angle towards this. And so if you don't know what that is, okay, if you're not sure, you haven't taken geometry, okay, what we're going to do is we're going to say this, okay? With our trig ratio that is opposite over adjacent is going to be tangent. So tangent of 60 degrees is going to be the opposite, our unknown, right? So we'll call that A, over 12. And so what I can do is I can tell you that 12 tangent of 60, again, if you have not done geometry, this might be looking foreign to you, but 12 tangent of 60 degrees is actually, this is going to be 20.8. And so now what we can do is you can actually find, you know, that this is going to be x plus 20.8 is our, this is going to be our width, right? And then our length is going to be something else that's equal to 900. So I want you to try and find what x is, or excuse me, what L is in terms of x. All right, and so that's the end of our video. Good luck on your assignment, and we'll hopefully see you in the Zoom session today or later.